In Unit 5, we covered ratios, rates, and proportions. So for number 91, it says find two ratios that are equivalent to the given ratio, 16/24. So I'm going to rewrite 16/24 twice here, and I'm going to show what I either divide or multiply by to get my new equivalent ratios. Make sure you show that work. That's how you would show your work here on this question. So to find my first equivalent ratio, I'm actually going to divide both numerator and denominator by 2, because I recognize both 16 and 24 are even numbers, so I know I can divide them by 2. 16 divided by 2 is 8, and 24 divided by 2 is 12. So my first equivalent ratio is 8/12. Now for my second one, what I'm going to do is I'm actually going to divide both numerator and denominator by 4, because I recognize both 16 and 24 are multiples of 4. So 16 divided by 4 is 4, 24 divided by 4 is 6. So 4/6 is my second equivalent ratio. I know a lot of you guys like to multiply both numerator and denominator by 10, because that's just adding a 0 to both of those numbers. That also works. You guys might have a million different answers than I do. It's totally okay. There's infinite amount of solutions for those two, or for that problem. And any problem like that, you just have to make sure you're either dividing or multiplying both numerator and denominator by the same number, and you'll end up getting the correct answer. For number 92, it says Sally earns $65.50 for 5 hours of work. At this rate, how much will Sally make for 12 hours of work? So since this is a word problem, I want us to remember it's complete sentence, complete thought. So we're going to end up wrapping here, restating our answer, or restating the question, actually answering that question, and then proving it. And our proving it is always what we do first in math here. So what we're going to do is we're going to set up a little ratio here. It's going to be 65/50 for 5 hours of work. Now we want to know for 12 hours, and since we can't make 12 by multiplying by a number, I'm actually going to find per hour first. So I'm going to divide both numerator and denominator by 5, so I figure out how much she makes for every 1 hour. So it's for 1 hour. When I divide 65/50 by 5, I end up getting $13.10. So for every hour that Sally works, she ends up getting $13.10. So I'm going to do a little line here, so I'm going to do a separate equation to figure out and actually answer this question. So I've done one problem, or one part of a problem, to find out per hour. Now the question is actually for 12 hours, how much does Sally make? So what I'm going to do is I'm going to take this 13.10 and I'm going to multiply it by 12 and figure out how much money Sally makes when she works for 12 hours. So I'm going to do this regular math here, just regular multiplication. So I get 15720. Now I have to remember I have 2 numbers behind my decimal, so I have to swoop the decimal twice to the left. So it ends up being $157.20. So that is my final answer, but I need to make sure I write it in a complete sentence. So I'm going to make sure I use the person they're talking about instead of just a pronoun like she. Use the name that they give you there, so make sure we're really clear. So we're going to write Sally makes $157.20 for 12 hours of work. Now, that's as clear as we can get. If someone were to read this answer, they would know exactly what the question asked us, and it gives us a nice, clear picture of what our answer should be. Now, 93 is the better buy question, ones I'm sure you guys love to do. So what we do is we're given 2 different situations. In this case, it's a 3-pound bag of apples for $2.99, or a 5-pound bag of apples for $4.99. It's hard for you guys to kind of see it on this screen, but you should have your packets in front of you, so that should be fine. So what we're going to do is I'm going to set up, again, 2 little ratios, so $2.99 for 3 pounds, and $4.99. Make sure I keep the units the same here. So money on the top, pounds on the bottom, for a 5-pound bag. Now I'm going to find out which, or how much per pound each of these bags are. So if I'm going to divide this first one by 3 to figure out per pound, and I'm going to divide the second one by 5 to find out per pound for this situation as well. So when I divide $2.99 by 3, my $2.99 goes inside the division house. Remember, top dog in the house, divide that by 3. Ends up being 0.996 repeating. Now when I divide 499 by 5, again, top dog in the house, so 499 inside that division house divided by 5, ends up being 0.998. Now when I compare those two, this 3-pound bag, for $2.99 ends up being the better deal because it's cheaper per pound, which is what we're looking for, which is why we did this this division in the first place. So what we're going to do is make this a complete sentence, complete thought, and say the 3-pound bag is the better buy. And then be done with that. Now, 94 says, at a fashion store, Grace bought 4 pairs of socks for $10 and 6 pairs of earrings for $15. Are these prices proportional? And it says use cross products to decide. So what I'm going to do is I'm going to set up a proportion here and see if they're proportional. So I'm going to have socks at the top, I guess socks in the numerator, so 4 pair over $10. I'm going to see if they're equal. So I'm going to put a little equal sign and that question mark above it because I'm not sure. 6 pairs. Remember pairs, if I put pairs on top on the first one, I got to do pairs on the top on the second one. And then for $15. So then I'm going to use cross products. So I do exactly what it tells me to do, find my cross products, that shoelace method, and I'm going to compare those products to see if they're proportional or not. If they're equal, then they are proportional. If they aren't equal, then they aren't proportional. So 6 times 10 is 60. 4 times 15 is also 60. So in this case, I'd say yes. These prices, and I say these prices because it's asking us, are these prices proportional? So yes, these prices are proportional. And then again, I am finished with that problem. Now number 95 says, solve the proportion D dollars over 4 tickets equals $72 over 6 tickets. Explain how you got that answer on the lines provided. So this already kind of tells us we need complete sentence, complete thought. It gives us even a spot to do it, so that's great. So what we're going to do is solve the proportion, and we can use, again, cross products to solve. It's kind of like the one right above it, but we're actually solving for something instead of just comparing. So when I multiply, I get 60 equals 72 times 4, which in this case is 288. Okay, so then what I want to do, I want to solve for D. So to get D all by itself, one-step equation, since this is multiplication, that's 6D, I'm going to divide by the number connected to my variable. So I'm dividing both sides by 6. That 6 cancels out, and I could figure out what my D equals. 288 divided by 6 ends up being 48. So D equals $48. Now, on this explanation, what I'm going to do is I'm just going to explain what I did. I used cross products to solve for D, which I found to be $48. And that's pretty clear. It's exactly what I did. So that's all they're wanting you to do there. That's all I want you guys to do is just explain what you did, how you found it. And some of you guys might have used a different way to find that answer. Just explain what you did. Make sure it's clear enough so I can understand, so I can follow your work with your words. The last question on this page says, Will is 5 feet tall. He casts a shadow of 3 feet at the same time that a tree casts a 9-foot shadow. So write and solve a proportion to find the height of the tree. So I'm going to do height over shadow, just because that's what's given to me. I could do shadow over height. Either one doesn't really matter, as long as you're consistent. So I'm going to do 5 over 3 equals, now I'm only given the shadow, so I have to put that in the denominator, 9. I'm going to put x in the numerator because I'm solving for x. You know what, I'm also going to draw a little picture, which I know some of you guys like to do. I love visuals. I think it's a smart idea. So draw a picture as well on this one. So I'm just going to draw Will here. He is 5 feet tall and a 3-foot shadow. Now I'm trying to find this lovely tree here, a blue tree. It's 9-foot shadow, and we're just trying to find how many feet tall this tree is. So what I'm going to do is use cross products to solve for this, because that's always the easiest way. 5 times 9, 45, equals 3x. Now I want to solve, obviously, for x, so I'm going to divide both sides by 3. Those 3's cancel out, and I'm left with x on the right side of my equation, and 45 divided by 3 ends up being a nice even 15. So 15 equals x. Now that's not our final answer. While it is correct, I need to make sure I'm doing complete sentence, complete thought. So I'm going to go back and make sure I answer the question. Write and solve a proportion to find the height of the tree. Now it's not actually flat out asking how tall is the tree, but that's really what we're trying to figure out. So what I would say is the tree, or something along these lines, is 15 feet tall. If I just left it as 15, that number 15 doesn't really mean anything to me. I need to make sure I put it into context and put a unit with it. Since we're talking about height and we're talking about all the height in feet, the tree is 15 feet tall. So that should be your final answer there.